Hi, class. I want to just do a short video on the Unit 3 project. Again, remember it's an extra credit activity, but uh, the material on the project will also be on the exam. So you really want to take a look at it, do your best, and see if you can get that figured out. And I just want to go over it, kind of help you get through it. Now, first thing you have to do is the table on your sheet is empty. I already filled this one out just to save some time, but these numbers in here were randomly generated. So we have a population of numbers from 1 to 26, and they're all equally likely to occur. And we want to get a random sample from that theoretical distribution. And it's a uniform distribution. So it says we're going to need 100 randomly generated numbers. And to get that, all calculators, all scientific calculators have a random number generator. So for the TI-84, I'll show you that one. If you go into math, and then when you do math, you'll see over here probability. And let's go over to that probability, and then go down to random. It's going to generate random numbers, but they're going to be integer values. So no decimal parts. They'll just be rounded off to a whole number. And so we've got the integers there. And then I'm going to hit enter. Now the lower number, the numbers are going to range from 1 up to 26. Okay. So lower, that just means the range. The numbers will be all between integer numbers, randomly selected, between 1 and 26 inclusive. So now how many do we want? We could type in 100 and give us a whole list, or we could just do them one at a time. I'll do that just then I'll put them in there. But so I'm going to go down to paste and hit enter. Okay. So if you don't have the newer calculator, if you have the older one, when you go in, it just looks like this. Random integer, 1, you type in 1 comma 26, parentheses, and then hit enter, and then 1 number appears. And excuse me, the number you'll see it's my first number the last time I did this was 24, but you'll take that 25 and plug it into your table, then hit enter again, and you get another one, 24, and you plug it into your table. And everybody's data set is going to be different. So enter 4 was my next number. See here, when I did it, I got different numbers. All of these are going to be different, but they're all going to be between 1 and 26. And you just keep hitting enter, recording it. Right, that would go there. And then the next number 11 would go in here, and so on. And you just go across, come back over here, and you start and fill them in, and you'll get down and you get 100 numbers. Okay. And then we don't need the calculator right now anymore, so I'm going to just put that down, and we'll take a look at the activity. So once you get all the numbers, okay, you can answer some questions. Use your randomly generated numbers to approximate. What we're trying to show here is, what do we mean when we say we're going to use approximations, right, for our probabilities? And when you go on and collect data, I mean, this is what you're doing. You're collecting a bunch of data. Hopefully it's a random set of data values. And then in random, remember, means every element has an equally likely chance of being selected. In this case, the numbers 1 through 26 will have an equally likely chance of being generated and showing up. So here's all our 100 numbers. It says, don't use probability formulas. In statistics, we don't use really, a bunch of probability formulas. We look at our data and see what the data is telling us. And that's a lot better way to approach doing statistics. So number 1 says, get the number 21 in one selection. So what's the probability of coming up with the number 21 in one selection? And what that means is, if I hit the calculator, right? So if I bring that calculator back up, I'm going to clear this out. All right, so now I'm going to do my math probability random integer 1 to 26 paste. All right, so all right, let's say that number 1 says here, getting the number 21 in one selection. That means coming over here, pressing this button 1 time. How likely is it that when I press that button, it's going to be a 21 is going to show up here? Okay, getting the number 21 in one press of that button. Well, the only way we really know that, at least can approximate it, is we have to go up here and see how many 21s came up. And if I look through here, I have, excuse me, I have a 1, and we have 2, 3, 4, 5. All right, so 5 of these 100 numbers, 5 out of 100 would be my probability then. Remember, probabilities, you have your sample space, you're taking a look at how many of the things occurred that you're looking for, which was a 21. We had 5 21s, out of the total number that are in there. So that just follows our basic rule for probability. And number two says not getting the number 21. If I come over here and press this button, what's the odds it's not going to be a 21? Well, if there's 5 21s, that means there's 95 other numbers in here. So 95 out of 100 would be our probability of not getting. And what's the probability called? That's a complement. It's what you're not looking for. So all right, let's get on the number. Getting the number 7 or 10. Again, if we come over here and hit that, what's the odds it's going to be a 7 or a 10 come up? Well, we got to see how many 7s and 10s are up here. So we got to count in 1 and 2 and 3, 4, and 5, right? So 5 out of the 100 numbers are either 7 or a 10. And that would be my odds then, 5 out of 100. All right, so number 4. What's the odds of getting a 5 and then a 15 in 2 selections? Meaning if I hit this button twice, I hit it, I get one number, I hit it again. So I hit it twice. What was the odds that it was going to come up a 5 here and then a 15 here? All right, 5 and a 15. What were the odds of that? Was it likely, not likely? Well, again, we can go up here and find that out. How many times did we run into a 5 and then a 15 as we looked across these rows? And if you look down through all of this, it didn't happen at all. Okay, it didn't happen at all. So we put 0. Right? That's what that's telling us. It's never going to happen because it didn't come up in our sample. Well, theoretically, may be different, but from this is when we work with samples and statistics. Sometimes things don't show up in the samples, and we conclude and figure that's not going to occur, and sometimes it does. But that's one of the problems with samples. All right. How about getting an even number or a number greater than 20 in one press of that button, right? If we had that, math and probability and random number and oops. And, right. Okay. So what's the odds when I hit this? It's going to be even or a number greater than 20. Okay, that could be a lot more likely because it could be even. That's half the numbers are even, and greater than 20, you got some of those. So we actually have to go through and see all of these numbers and check it out. Is that even or greater than 20? Okay, that's 1. That's even. Okay, that's 2. That's 3. No, this is not even It's not greater than 20. We don't count that then. So if I got 3, no. Oh, 4, because it's greater than 20. 5, no. 6, no. 7, 8, 9, 10, 11, 12, 13, no, no, no. Okay. And you count them all up, and I went through and counted 54 out of 100. So that's my probability. So let's just click this and see what's the odds, right? Is it going to be even or greater than? Well, actually, there's a good chance. Nope, didn't happen, right? Okay, let's move on here. Now, getting the numbers 3, 25, 11, 17, and 9. What's the odds of hitting this thing 5 times? 1, 2, 3, 4, 5, right? What's the odds that I hit that thing 5 times and it came up 3, 25, 11, 17, 3, 25, 11, 17, and 9? Well, it didn't happen this time. Is that very likely to happen? Let's look through our data set. Let's see. What was the first number? It's supposed to be a 3. So that means we've got to find a 3 first of all. There's a 3. The next number has to be a 25. So nope. So no, that didn't work. And we got to keep, there's a 3 and then a 25. No. Right, and it, nope, didn't happen. So we just have to put 0 there and just assume that it's not going to happen. Theoretically, yes, it will, but not according to our sample. And then how about getting 3, 25, 11, 17 in any order? So we could have 25, 11, 17. You got to go through. It takes a little work to check that out, but because like here's a 17, 9, 11, 25, 17, 25. Those are 2. Nope. No. 17, 11, 11. Does 11 occur in? No. Not. Yeah, there's a 17 and 11. And we need a 25, 3, and a 9. And nope. So again, a little bit of work. Here's a 3, 9, 17. No 25. There's 11, 9. No. Not all in a row like that. So 0. All right. So that's the first part of the project. And then we go to the next part. So the first part is a sample. The second part is theory, right? Here's a theoretical probabilities, but same idea. Here's a sample space. This was a sample, right? Sample. This isn't a listing of all things that could occur. It's just what happened to occur in 100 trials. Now, this is just saying that on any given single trial, any one of these things should come out. And that's true. Any one of these single trials that we look at, any one of these single numbers are all going to be numbers between 1 and 26. So sample space, what's the odds of getting a number 21? So what's the odds that we go back up to the start here and I hit this random integer and it came out to be a 21. Well, see, actually it did right here, right? After 1, 2, 3, 4. So we know 21 is going to occur. Well, how often? If we kept hitting this button, how often is 21 going to show up? Let's see, it came once. I'll keep doing this here. And I might have to do this for a while. All right, so it seems like we need, there it is, it showed up again. So after about 20 or 30 times. Well, theoretically, there's 121 in these 26 numbers. So it's 1 out of 26 is our chance of it coming up. Is this a simple or compound? Simple event. We're just looking for one thing. And then the number 9, not getting a 21 in one selection. So what's the odds that I click this and it doesn't come up 21? Well, there's a lot of other numbers up here. In fact, there's 25 other numbers. So 25 out of 26. And that's called the complement of that. All right. How about getting 7 or a 10? Well, there's 1 7 and 1 10. And these are mutually exclusive. They cannot occur at the same time, right? In one selection, They're independent trials, but this is just a single trial, right? In one selection. So if I hit this key, what's the odds it's going to be a 7 or a 10? Well, 2 out of 26. Because that's 2 of the numbers that are up here, all the 26 numbers. That's a compound event because we see the or in here. Probability of a 7 or a 10, it's compound. The probability rule that goes with this is additional. All right. How about 7, 5, and then a 15? The odds of a 5 and then a 15. So again, that's if I hit it again. What's the odds it's going to be a 5 and a 15? Well, they're independent events. Every time I hit that button, every number has a 1 out of 26 chance of occurring. So we simply multiply. We're going to use the multiplication rule. 1 out of 26 times 1 out of 26. Remember, and means to multiply in probability. So 1 out of 26 chance of coming up with a 5 and a 1 out of 26 chance of a 15. It's 1 out of 676. Multiplication rule. The events are independent. All right, getting an even number or greater than 20. Now, we had to count them before. Here we were just counting all this stuff up. Well, we could use a formula. Even number, there are 13 out of the 26 numbers here that are even, so that's 13. Greater than 20 is 1, 2, 3, 4, 5, 6. So 13 plus 6 is 19 out of 26. Minus the ones we counted twice. Remember that. Which numbers are both even and greater than 20? This one is 22, 24, and 26, so minus 3. So 19 minus 3 is 16 out of 26. That's the addition rule. All right, and those are non-mutually exclusive events because they can both happen at the same time. What's the odds of getting a 3, 25, 11, 17, and 9? Well, that is 5 because that's and this, and this, and this, and this. That's like, again, hitting this thing 5 times in a row and getting 3, 25, 11, 17, and 9. And no, we didn't get that. So it's the multiplication rule. This number has a 1 out of 26 chance of occurring. This number has a 1 out of 26 chance of occurring. This number has a 1 out of 26, 1 out of 26, 1 out of 26. That's 5 times we have to multiply 1 divided by 26, or 1 over 26 to the 5th. Multiplication rule. And then what's the odds of getting those in any order? Well, we got to know how many ways we can order these things. It's going to be 5 things, 26 to the 5th, but we have more options since we can reorder these and look for them. In fact, we have 120 because we have 5 and 4 times 3 times 2 times 1. Different ways we can organize these things. All right, number 15, list 3 subsets of this set. And again, you can make up your own. I just picked 5, then 3, 25, 11 is a subset, 4, 8, 12, 16. I made those up, right? These are all just made up sets that came from this one big set up here. We could think of that as a universal set. How many different subsets could be created from this? Well, there's 26 numbers, so it's 2 to the 26th power. How many proper subsets? There's always one less set in proper subsets. So 22 to the 26th minus 1, the set itself. And yes, the numbers, when you compare them and you look, they're gonna come up pretty darn close. So for what we're dealing with for this sample space, is 100 seem pretty good for, come up with probabilities? Yeah, 100's good. It doesn't mean it's good for every sample you go out and collect. In this case, it seemed to work fine. All right, but that's really about it. So again, that's the Unit 3 project, and that will also, those ideas will be on the test. So make sure you look at this, If you get it completed correctly, you'll get the 5 extra credit points, and then but there'll also be things like this on the formative guide. You want to make sure you look at that also. Okay, so again, remember the test is going to be online, and you'll be able to see that coming up pretty soon.